In this video, we will talk about what do the square root of x squared and the quantity square root of x being squared simplify to. It seems like at first glance that they should just simplify to x, but it turns out for one of them that's not the case, and we'll investigate why. Alright, so I'm going to keep track of x, and first let's do square root of x squared, and I'll make a little table, and I'm going to plug in 3 for the x, and negative 3. If I plug 3 in, I get 3 squared, square rooted. So this is the square root of 9, which is just 3. Remember that when I square root a number, the output is always non-negative. Okay, when I plug negative 3 in, I get negative 3 squared, and I square root that. Okay, order of operations, I got to work inside out. Negative 3 squared is positive 9, and then I square root that, and that's 3. So because of that, the square root of x squared cannot just be equal to x, because if it was, whatever I was plugging into it, I would always get the same thing out. So what's happening here is because that's squared, it's taking any negative input and making it non-negative. But I have a function that will do that. That'll take all the negative inputs and make them non-negative, and that's actually absolute value of x. That's what the square root of x squared simplifies to. Okay, the absolute value is necessary because it guarantees the output is non-negative, just like having the squared on x squared does. Okay, and let's write the domain of this. The domain of this function, I can plug in any number that I want to in for the x, because when I square it, it'll be non-negative, and then it's just fine to take the root of. So the domain is all reals. There's actually a mathematical shorthand symbol for all reals. It's kind of an R, but with a double line here, and that stands for all reals. All right, so I'm going to box this. The square root of x squared isn't just x. It's the absolute value of x. So next, let's ask the question, what is it if I reverse the order? What is the square root of x, like this, being squared? All right, question mark. Okay, let's make a table of values of x and the square root of x quantity squared. And just like before, let's try plugging in 3 for x and negative 3. If I plug 3 into this, we are going to get root 3 quantity squared. So this is root 3 times root 3, which is 3. If I plug negative 3 into this, we're going to get root negative 3 squared. But root negative 3, I got to work inside out, order of operations. Okay, this is undefined. Undefined, which means that's what I get if I plug negative 3 into this. I just cannot, I am not allowed to do anything to that root negative 3. If any part of my expression is undefined, the whole thing is undefined. If we allowed ourselves to use complex and imaginary numbers, then we could simplify this, plugging in negative 3. But in our class, we're not going to allow complex numbers at all. So for our purposes, this is undefined. Okay, so for the square root of x squared, I can't even plug in negative numbers at all. So when I try to simplify this, I'm only worrying about what happens if I plug in a non-negative number like 3 or 0. And when I plug in a number like that, I do just get x out. Okay, and the domain here is different. It is x is greater than or equal to 0, or an interval notation. I could write 0 with a bracket onwards to infinity. Okay, and let's put this in a box. So that is what the square root of x quantity being squared simplifies to. So just to convince ourselves, here's a graph in Desmos. Okay, so first I'm going to draw in y equals the square root of x squared. And notice that that has that absolute value of x shape. Okay, so that's good. And here's the other one. If I switch the order, that looks like y equals x, but it's only the part of the graph where x is greater than or equal to 0. So that matches what we got algebraically. So we've finished our third goal, to simplify the square root of x squared and quantity square root of x being squared. We've kind of skipped goal 2, which was finding horizontal asymptotes, although we did briefly talk about these. We'll revisit that in another example.